sign across that value, then it's possible that it's a point of inflection, but only if the original function is defined there, right? So if it's changing sign but the original function doesn't exist there, then we can't consider that a point of inflection. That's one of those special cases, again, that we have to just look at by a case-by-case basis. This is just for the nice, neat ones that we get for 90%.
It would only be a point of inflection if, like, the signs are different on, like, opposite sides, right?
Right, if it goes from positive to negative or negative to positive.
Not if it bounces.
If it bounces in the second derivative, no. If it bounces in the first derivative, yeah, though. All right, so we have some more problems here. This is actually what I had up on the blog for the notes today. This one has one neat little problem that we'll go into. So first problem, you'll notice that the domain of this function goes from -3 to +3. So we've got a restricted domain, so we're not going to have to do infinity for any of our intervals for this one. So I want to know under what interval is the function decreasing? And you'll also notice that I asked for a justification. What? It really wouldn't make sense for me to give you the function, because you could just look at it and say when it's decreasing. Yeah, I know. Still.
Yeah, never mind.
Because then you don't need any calculus to solve the problems, right? Okay. So Isabella, do you want to give me the answer to the first one? When is this function increasing? Remember, this has a closed interval domain.
-3 to -2.
Uh-huh.
0 to 2, and then 2 to 3.
Sure. And how would we justify the fact that the function is increasing in that interval? What would be the justification that you would have to write?
Because the graph of f prime of x is positive.
Because f prime of x is positive. So, yeah. Because that's what you did to answer it, right? So you just write that out.
Is that the graph of f prime of x?
Yeah.
That's right.
Okay, second one. For what values of x does the graph have a relative maximum? Justify your answer. So once again, when you see this, you think I got a relative max, which means my derivative must be 0 or undefined. We don't have to worry about undefined because that's continuous and differentiable. And it also has to be concave what, Vivian? Relative max, concave down. What does concave down imply about the first derivative then? Or it's decreasing, right? Okay. So, why don't you go ahead and give me that one, Vivian? What would the relative maximum, where would the relative max occur? -2. Yeah, -2. And then your justification for that would be that f prime of x is 0 and f prime of x is decreasing. You could have also, like Vivian said that the derivative is going from positive to negative. You could have also said that the second derivative is what? The second derivative isn't concave down. The second derivative is what? Negative. Concavity in the second derivative is irrelevant, right? If we're looking at the second derivative, we don't really care what the concavity of the second derivative is. We just want to know when it's positive or negative. Because if it's positive, it's concave up, and if it's negative, it's concave down. Okay? So you could have said that too. How do I know that the second derivative would be negative? Because the first derivative is decreasing. So the derivative of the first derivative is the second derivative, and a negative derivative means that the function is decreasing, right? Make sense?
Yeah.
So there's a lot of ways to justify relative mins and relative maxes. You can talk about decreasing, you can talk about the second derivative, you can talk about it going from positive to negative. For what values of x is my function concave down? Yeah, Michael.
Okay, wouldn't it be when x is decreasing, right? So it'd be from -3 to -1, and from 1 to 2.
Okay? And then our justification would be what?
What? Oh, because f prime of x is decreasing.
F prime of x is decreasing. Now you would not be able to say, because f prime of x is going from what? Positive to negative, would you? Because look right there. What's my derivative going from? Positive to 0, right? Okay, where are our inflection points? Krista? -1, 1, and 2. Sure. What's special about the critical point at 2? I'm sorry. What's special about the point of inflection at 2? What? It's not a critical point? It is a critical point. Why would it be considered a critical point? Because the first derivative is 0, right? So, yeah. So 2 is both a critical and a point of inflection. 1 and -1 would just be regular points of inflection, though, right? That are not critical points. Okay. And then our justification would be that my derivative changes from decreasing to increasing or increasing to decreasing, which is basically the definition of a point of inflection, right? Or you could just say the concavity changes from up to down or down to up. Yes?
You say the second derivative is 0 at those points?
No. The reason why we can't say that the second derivative is 0 is what happens if the second derivative was a parabola on the x-axis. That would not be considered a point of inflection because it's concave up and concave up. So the fact that our second derivative is equal to 0 there isn't enough information. Not only does the second derivative have to be 0, but it has to pass all the way through the x-axis, meaning it's got to be positive on one side and negative on the other side. Does that make sense? So I mean, that could be part of your answer, but you'd also have to say that it passes through. All right, so I'd like you to try to do this one yourself. There's the derivative. I'd like you to use all of this, use this graph right here to graph what you think the original function looked like, and use the fact that f of -3 equals 0. So once again, this is like last night's homework. I would like you to graph this based on the extrema, meaning you know where the maximums are, where the minimums are, and where all the points of inflection are, right? And you also know the starting point is -3, 0.